Hi, my name is Syed Mohammad Hamza, and today I'll be demonstrating to you my final project for SIT210 Embedded Systems Development. Firstly, I would like to explain what project I have created and why. So the name of my project is House Safety System, and it has two major safety implementations. The first safety component of my project is based on fire alert systems, which will notify the user if there is a fire in the house and will also implement a safety measure accordingly, like a watering system or an opening and exhaust. My prototype is most ideal for places like kitchens where there could be a chance of fire, and it automatically turns on an exhaust in response to that. Secondly, the other implementation for the safety of the house is a security implementation, which uses motion sensors to detect motion inside the house and turns an alarm on and also notifies the user if there was motion when there should be no motion in the house. The second implementation can be used near doors or rooms based on the user's requirement. These two implementations together make up my whole house safety project. Now you must be thinking why I'm using two separate systems for two scenarios. As I have already explained in my pitch, the whole idea of this project is to create a system which can not only detect fire but can also be implemented for the security of the house, which creates a smart house safety and security system together. Now, there are many security and fire control systems sold together, but they are really expensive, and that's why my system is a more cost effective, and it has both the systems in one project, which the users can use according to their needs separately or even together.
So before I go on to the functionalities, I would like to tell you what devices I'm using for my hardware and so basically I'm using a Raspberry Pi, I'm using an Arduino, I'm using an argon particle, and I'm also using a motion sensor, temperature sensor, a buzzer, LED lights, and I'm using resistors and jumper wires and
Breadboards.
so these are the things that I'm using for my hardware. All right. So So right now I'm going to show you how my system works. So basically if I say turn system on, you can see here that I'll get a message that says system on and it starts to check the values of the temperature. Right now it's checking the values which are coming to be 16, which is higher than 15 that I have set for the temperature sensor. And after checking the values, it sends a notification to my phone, and it also starts sounding a buzzer and a LED light through the Raspberry Pi. So basically, as you can see right now, I've got a fire alert notification which says that there is a fire, and my Raspberry Pi is connected to the Arduino, which through the I2C bus, and it's opening this LED. So this LED is basically representing an exhaust fan, which I couldn't get, so I'm using an LED instead of the exhaust. And this represents that the exhaust is automatically on as soon as there is a fire. But the thing is, if after I get if I get this alert, I can just turn the safety off. If I want to turn the safety, if I want to turn the buzzer and the light off in case of a fire, and it turns the exhaust and everything off when I turn the system off. And as you might have seen, I'll show you. So basically, when my fire alert was on, it checked the values from 0 to 1, 2, 3, 4. So this basically showed like as soon as I got a value of 16, it didn't directly alert me or didn't directly switch on the LEDs and say that there's a fire alert, because it could be a false alarm. So basically I'm checking the value for 5 seconds, and if for 5 seconds the value is still on, it sends a fire alert message to my phone through IFTTT, and also it publishes to the client in MQTT, which Raspberry Pi subscribes to, and turns the buzzer on and the LED on. So that's the delay to make sure that there is actually a fire and it's not a false alarm. And also when the system is on and there's a fire alarm, I'll show you the second scenario when there is no fire. So right now I've turned the system on, and so now I got a value of system on, and it's again showing that there's a fire alert. So what happens if I take the temperature sensor off? So basically when I take the temperature sensor off, the fire alert goes off. That means the value has gone down. So basically there's no more fire anymore. And if there is no more fire, the second scenario is I get a second notification which says fire is controlled, as you can see right here. So this is my fire alert system, and So this is my fire alert system, which basically tells the user, notifies the user can control it to turn off the safety, and the user can also, after turning off the system, after turning the system off, the user can choose to turn the exhaust on if he wants to. As you can see that the light of the exhaust is on, which means I can control the exhaust manually from my HTML as well. So if there's a fire and I want to turn the exhaust on, I can turn it on manually as well, and I can turn it off as well. So if there was a false alarm and the exhaust is on, I can turn it off as well. Apart from this, my other aspect of the project is the security side. So in the security side, I have an option for the user in the HTML which says turn security on. So when I press turn security on, I should get a message here which says security is on. Okay, yeah, so I got a message that says security is on, and the motion status is right now is 0, which is being sensed by this motion sensor right now. So what happens if I have a motion in front of the sensor right now? See, so now as you can see that I have got a message which says motion is detected. It delays that message for 5 seconds and checks again if their motion is detected, and if the motion is detected, the user is notified through an IFTTT notification. As you can see that I have got one here, and it also checks the values for 5 seconds. So basically if there was a motion for 5 seconds or at least 5 seconds, then the notification is sent to the user. Otherwise the notification after the motion is stopped, it's again sent. So I must have since the motion has stopped, I must have gotten another notification that says no motion detected anymore. And this way the user can choose to call the police, or for future improvement the user can use a camera feed, live feed, to check if what is happening inside his house. Unfortunately, I didn't have a camera to implement into my project, so I couldn't use the camera. So I can also turn the security off from here, which will turn the security off. As you can see right now that the security is off. So the scenario in which the user uses the safety on can be multiple. So basically when the user is sleeping at home and he wants to have a check that if there is a fire he can be alerted. So that's why I have used a buzzer and LED light to indicate inside the house. If someone is already present, they can easily check and see what's happening inside the kitchen area wherever the fire is. And if the user is also not in the house, I'm also sending a notification, as I have already shown you, which the user can use that to call the emergency services depending on how big the fire is. And apart from that, the motion sensor as well, it checks the values of the motions, and then it tells the user through the IFTTT that there's been motion detected when there's no one inside the house. So the safety side of the system can be used even when there are people inside the house, and the motion sensor and the security part can be used when there is no one inside the house. So another thing that I wanted to show you with my project is when I turn this safety on. So basically the system is on, as you can see right here. When the system is on, the values, it checks the values. I don't want to fire the alarm right now. Oh, alright, so basically the alarm is on. I'll just take the sensor out, so the alert is off. So this green LED is representing that the system is basically on right now when there's whenever I turn it on. So if there is someone else inside the house and they want to use the stove or the area where the setup is, then they can see this light is on and they can manually override it with a switch to turn the system off. I didn't have a switch right now, otherwise I would have implemented it into my project. And with the switch you can manually turn the connection off for the sensors, and you can do your work whatever you want and then press the switch again to turn the system on. So basically this will allow people inside the house to use it if the system is on. So basically all these things combined, I have implemented two separate systems. I'll just turn my safety off so I can talk about my project in the final conclusion. So yeah, so I have a argon particle which is taking the values for the Raspberry Pi and sending it to the MQTT server. If the value is greater than 15, which I have just implemented for the room temperature, I will actually use a higher value for the fire, which can be above 35-40 degrees. So basically this will send the data to the MQTT server that there is a fire if the temperature was high. Raspberry Pi will subscribe to that and turn the alarm on and also turn the LED on so that if someone is inside the house they can hear it. The Raspberry Pi is also connected to the Arduino to turn the exhaust system on. So basically, I used the I2C for the Arduino because I didn't want to connect the exhaust with the Raspberry Pi, since there could be multiple scenarios where people use different things to control the fire, for example, a watering system or closing the doors or room, implementing something else. So Raspberry Pi can be used as a master device to control the Arduino to do other things. So basically, this can just be there to fire the alarm and control the other devices, and the Arduino can implement the other implementations, for example turning the exhaust on, turning the watering system if there is a water system or something like that. So that's why I use the Arduino along with the Raspberry Pi, and the user has the opportunity to turn the safety off, turn the safety on, exhaust off, and the security aspect on through the HTML without doing anything else.
And also my HTML is connected to the MQTT, and my Raspberry Pi is subscribing to my HTML exhaust function directly. So whenever I press the exhaust on or exhaust off, it automatically sends MQTT's message, which is subscribed by the Raspberry Pi, which then tells my Arduino to turn the exhaust on or off.
The motion sensor I've used is just one in here. I was initially going to use two motion sensors, but one of them didn't work, so I had to only use one of the motion sensors, which is right here. And this LED is basically representing an alarm system inside the house, which I didn't show you, so I will just show it quickly to you. So when the security is on, this should turn the security on. Yep, the motion is not detected right now. So if I just move my hand, the motion is detected, and you can see the LED is turned on. This means there's a alarm inside the house which goes off as soon as motion is detected. However, this motion sensor is not detecting motion for a long period of time because I was not moving my hand, so it turned off and the light is turned off. So when the alarm is turned on, when the notification, I have already shown you that I get a notification on my phone when the motion is detected, and the user can be notified through the notification, and he can do whatever he wants with that and improve the project later on if he wants to include the cameras or anything else like that.
So this is my system, which is implementing two major smart housing systems together into one project. I hope I have been able to explain everything properly regarding my fire system and also my security system. And this is the final project. So I hope you liked it. Thank you for watching.